Hello, and thank you for joining for this BIM4N webinar. BIM4N is a European funding project that aims at developing BIM-based tools for the fast and efficient renovation of existing buildings. Here we are closing this series of webinars with demonstration of the tools that have been developed, and in this case in relation to the French pilot building. So I'm Antoine Duguay, working in Nobatec in F4. And here, as coordinator of the BIM4N project, I will demonstrate 3 different tools that were developed in this project. So the initial point is considering the needs of a French social housing organization, here Polylogis Logirep. They are managing more than 100,000 dwellings across France, and more or less they carry out 10-15 buildings renovation per year. Their internal process is that they have a committee that identify the buildings that need to be renovated. Here the criteria are quite various. It can be based on their degradation, the state of the building, its energy consumption, if there are potentially also more politics related consideration, for example, an agreement with the municipality. Once they do this first assessment, they select a limited number of potential buildings to be renovated, and a manager is assigned to consider this building as potentially to be renovated, and there is a small budget that is allocated. And so there starts the investigation of the needs of the potential renovation for each of those buildings. So it's some collecting, they collect information, they define the objective, they assess the cost. You might run some energy audits or more even asbestos audits. And so it's quite in line with the process, the workflow that has been developed in the BIM4N project. But at this stage, one could say that it's not really digitalized, and they repeat the same process again and again. So there is some margin for improvements. So here what we consider is a set of buildings in the suburb of Paris. This is a typical French suburban architecture. So with poor architecture value, and there is a need for its renovation. It has already been renovated in the 90s, but a new, let's say, a renovation is considered. And so those are high-rise building towers, which are quite identical, and for which the discussion about the renovation is both about its energy, let's say behavior, energy performance, but also about giving more value to those buildings, especially for the tenants and for the people living around it. What we might add as information, so there are in total almost 400 dwellings, so it's quite an important renovation that amounts to more than 10 million euros. The renovation design that had been selected is about mainly the envelope of the building, so external thermal insulation renovation, improving the air tightness, the air renewal of the dwelling is also to be modified, and the central gas boiler for heating and domestic water will be replaced. And then there are also obviously some other renovation which is not related to the energy performance, which is about the bathroom, the electricity, internal areas, external areas, security, and so on. We underline it here just to show that obviously energy is not the only criteria, and sometimes even it could be secondary if we consider, for example, security or other such criteria that could trigger the renovation. The objective of the development of the tools here were to digitalize the process and to consider at an early stage of the project the costs, the energy consumption of the existing state and under potential renovation scenarios, the CO2 equivalent emission under those different scenarios, and also, which a bit more important nowadays, it's about the comfort in the dwellings over the summer. It has to be quite quick but reliable, and also there is the idea of saying, okay, it's an internal process in this case, in social housing, in this social housing organization, but if there are some elements that could then be handed over to the contractors, it will be even more useful. So what I'm going to present to do some demonstration is a workflow of an early assessment of the potential renovation with quite easy to use tools. So it's in this case a building owner, but those tools could also be used by external contractors in the early design assessment of such a process. So what we start with in this case is 2D layouts of the building, and from those 2D layouts we are going to create some AFC model, a BIM model using plans to BIM by WiseBIM. And afterwards, this very BIM model will be imported into another tool that we will show, which is the BIM Solar tool by NRBIM. And the last one will be the energy renovation scenarios assessment with the tool which is called Renovation Manager. So I'm starting with a short presentation of WiseBIM, and then I will use even the tool. So WiseBIM, which is a French startup that few years old and that has developed Plans to BIM. Plans to BIM is a software, online software that will import 2D plans, 2D layouts as images, and by identifying the patterns through artificial intelligence, it will recognize the elements composing the building, walls, windows, and so on, to create a BIM model in IFC as a standard. So I'll go quick, but it's online web tool. It's a web tool in which you will have an access. You will use as inputs the 2D layouts, and through different steps, you will, at the end of the process, create an IFC file that you can either have as a 3x3 or IFC4. What's key also, it embeds a viewer, it embeds an editor. I will demonstrate. And so it allows in the model to recognize wall, windows, doors, slabs, spaces, which is information which is on top, let's say, of the geometry. It's information about what is wall, what is external wall, internal wall, the window, and even properties of the wall can be added. So that's the process of collecting such 2D layouts. Either it exists before the even considering the renovation, or it has to be created by other kind of alternatives, such as a scan or a surveyor that will create those 2D layouts. And so Plans to BIM is, as you can see, is quite it's a web-based tool in which you log. You can create it's free to create an account. Then you create a project. Here I have a project which is already created. In this project, I will find my different buildings. In a building, I will find different floors. So in this case, in the Joinville building, this is the one that we are considering, I will import the plan layout. And from this very layout, I will then, well, it will recognize the PDF file I just imported that you can see here. I will import it. It is now uploaded, and then I will work on this very case. You can see the layer. So I will open it in the modeling tool, where I first need to, as an input, define the scale. So here I'm just going to zoom in. It's pretty easy, the typical buttons. And I recognize that in this, well, kitchen, this lens that I can adjust a bit is 445 meters. I will just put it there. Validate. It says that there are 74 pixels for a meter, which is quite, it's okay. Let's just say it's not perfect, could be a better quality. And when I've got this scale, okay, I can actually then run the automatic detection. I will run the full detection. I could do as a step-by-step, but let's see how it goes. There are parameters as to recognize the wall thickness. It might not be as much as those. And minimum length, so you can adapt a bit, okay? I will now run the automatic thickness. It is done on the wise beam 7. And you can see it's a quite short process. It will allow me to tell you that it is, again, free to use at this point. You are going to create beam models that you can edit, and you are going to pay only if you export it as an AFC file. So you can try it and see if the results fit your expectation. So you can see now the model that has been created, and now there's more information. You can see there are some blurry elements there and there. So it can be pretty easily, well, as you can see, I'm going to remove some of them. So I'm not going to the full process of modifying that. There is a stair here that has been poorly recognized. Okay, but I can, for example, use a wall and modify, oops. Okay, I'm going to use, I might have, okay, box selection, I'm selecting this, and you can see that I'm moving it. I want to rotate it, but that, I'm opening too much point, as you can see at this stage. It's the zone I'm selecting. I'm not actually selecting a wall, okay? So here, this wall, okay, I'm trying to fix some elements. You can see that the zone is created. I'd be happy if I could turn it, because it does tell me that it's a wall item. I want to rotate it, and not using this one, but right now I fail to move it. Yeah, so as you can see, I can modify it. I'm not clearly an expert user. It should be better done by someone who has been, let's say, testing it a bit more. Okay, so they just say that you can, by this, using this heater, you can adapt quite easily the different elements. You can see that this is a door, which is recognized. This is an internal door. Those are external windows. And you can adapt a bit the balcony. You could adapt, for example, this element, which is not well placed, and so on. So once, and yeah, I should be the one working on that, but once you're happy, you can then export the model. At this stage, you can also just check in an internal viewer if it's well recognized. And the very problem that I had noticed are here, the slab is not closed. There are some blurry elements that should be fixed, let's say. So although it's not, let's say, a perfect recognition of the file, it's still something which is easily fixed, and you can do it quite quick. Okay, then if I am happy with these elements, I can save it, and then I will create potentially few floors like that. Okay, and once I have the few floors, I will create the full building. So the full building could be seen as an assembly of different floors, as you can see here. And I'm just saying that the 11th is, and so on. I'm creating a building made out of 4 different. Okay, and once I have that, I should be aligning those 2 floors that at the moment are not aligned. Okay, the resulting process, when done a bit more carefully, is an IFC file such as this one. Okay, so this was done by let's say half a day trained user in half an hour. So you can see different stairs. So another tool is the Beam Solar tool. I'll be quick. The Beam Solar tool is a tool for urban planners, architects to assess the potential of PV installation for existing building. So the idea is to import a BIM model to assess the installation of PV panels, to assess the electrical production, and even potentially the cost of it. So you import a BIM model, and then, as you can see, you're going to install some PVs and so on. So Beam Solar is a desktop software. It's free again, so you can download it. You have to create an account, and then it's a standalone software that runs on your computer where you import a BIM model. It could actually be also a 3D model, which is not BIM. You're going to easily install some PV panels, as you can see here, either on the facade or on the roof with tilted elements. Those elements are then going to be assessed regarding the solar irradiation. Previously, one has to choose the exact location just to, let's say, have some weather data. The technical outcomes, the outputs of this software is the electrical production, the potential losses in the wiring, and even a cost assessment and self-consumption under different scenarios. It's key to see that, as you can see in these dynamic images, that you can see either a yearly analysis, a monthly analysis, a daily analysis, or even hourly analysis. So it opens the possibility then to check the electrical production against electrical consumption. Again, very shortly, I will show that this is the very same building that has been at the beginning imported, where you can see regarding the sun pass, its irradiation. I can see at different moments. The one thing which is very important is the PV panels that you're going to install come from an external library made of PV panels as BIM objects. Those have been provided by the very same manufacturers. So if I change, I choose one, this is the one that I now have, and if I choose to install it on the roof, as you can see, I will have it. I will quite easily duplicate it just to assess the potential installation, and as such, well, obviously you can do it a bit cleaner than that. I've got this huge PV installation on the roof. I will then consider the wiring of the different elements. Okay, I can even say this is, I will just choose the first inverter and go with automatic wiring, okay, in between each of those. And from there, it's possible to assess for those elements, okay, the monthly production, as you can see, for each of those panels. And yeah, and once we have that, you can check on those different scenarios the network consumption and the self-consumption if there is this electrical load from the building. So again, this is a free tool that you can find easily online that is based on BIM to assess the potential of solar installation. Philippe Alamy is the main developer with his company, which is called Enerbeam, a French SME. Another tool is a renovation manager. The renovation manager, we will consider a set of buildings, a building management portfolio that for those buildings, we will consider different renovation projects. And for those renovation projects, we can consider renovation scenarios. So for example, there could be a low ambitious one and a high ambitious one as project. And then we describe the potential renovation of the building. The idea is, so we start at buildings in this portfolio, we then create those renovation projects, and then we focus on the energy renovation, and we run those simulations. What's key is that the building is composed of envelopes and systems, an envelope being walls, window, roof, walls, doors, and even the infiltration, which is related to each of those elements. And the HVAC system are mainly, I mean, not only HVAC, but ventilation, heating, domestic hot water, and lighting. And yeah, and the usage, the internal behavior of the tenants, let's say, is fixed. It's made under some hypothesis, but it's not something that could be changed. The idea being that it's not up to it's not part of the design. It's rather something which is related to the tenants themselves. So the idea is to then have to explore the results dynamically in graphs, and then to export the potential energy consumption and so on. So I will demonstrate that. So this is the renovation manager. Similarly, one gets to log on that. It's not at the moment, it's at a stage of development that's not allowed to have external user. Hopefully it will reach this point in the coming months or year. So in this case, we have a building that is created. We are going to use the fact that we are going to consider its renovation. So first we need to add some information, basic information about the building regarding its facade area, well, the typical number of dwellings and so on. Then we will use an internal initial file that is used for energy simulation. In this case, it's done through the Energy Plus engine. So it's an IDF file. More information could be found in the BIM4N website. A weather file is also dropped here, and you can see that it has been already downloaded from the one computer. So those two files have been uploaded in this case. And the idea is to first describe the building. So the domestic hot water, it's pretty straightforward. We select if it's done with, in this case, a gas boiler, electric hot water, or solar collector, the volume of it, and so on. And so we do the same for each component, the heating system, and typically the window for which we are going to choose its frame material and its thermal characteristics. Okay. Similarly, the wall is made of layers in this case of concrete and insulation, for which we specify the characteristic and the thickness. So once this is done, the existing state of the building, we can consider some potential modifications. So modifications is, okay, my heating system is initially the one I just showed, but it could be done, it could be also a modified version with a higher efficiency, for example, that comes with a cost. Similarly, the window that I just showed is, I can consider a double glazing window with better characteristics, or even a double glazing window, but in this case, the frame material would be made of aluminum in one case and wood in another one. And the third one is a triple glazing window, so with different characteristics, okay? So then when I consider all those potential modifications, I'm facing quite a lot of potential renovation scenarios. This is not the one I want. So, well, if I go, I'm just using, let's say, dummy test here. But if I want to consider a case, the one that's been done here is we consider the domestic hot water boiler modification. We consider the 3 different heating systems, and we consider the modification of the windows, And at this stage, the combination of that is 64 potential scenarios. We are going to assess that. I'm not going to run the simulation because it has already been run. And so I'm just showing how it's presented. So all results are shown in this graph, which goes with the thermal comfort and against the energy consumption. So the lower the better for thermal comfort, and so the best are on the bottom left. Those ones should be the best scenario. So I can select those. I can see how they are made, and their characteristics are shown here. So typically, this one is one with the existing domestic hot water, but also the modification of the heating system and just double glazing window. And the different energy consumption are shown into the circular diagram, but also the carbon dioxide emission, the thermal comfort, and the cost of it. So this is what the renovation manager is about, to compare, to explore those different scenarios, and for a potential social housing organization to be able to themselves be able to assess the potential renovation. And from there, this was 3 different tools that I showed, and more can be found on the Beam4Rent website. And that will be it for this French pilot demonstration.